Analysis of structure, the basics. Before we go into the step-by-step process of analysis of a structure, let's look around for some of the example structure. If you look at these breeze truss on the left side, they're basically some arrangement of some triangles. If you look at this tower crane, if you look closely, there's some arrangement of some triangles. The transmission line, the bicycle frame, roof truss, motorcycle, this is our formula car chassis. They're basically, you can see, made of using some triangles, simple triangles. So the basic that a structure that makes all of these different complex structure is basically triangles. So therefore we'll show you first the step-by-step guidelines using this triangle, and then you can apply it to solve some complex scenario, basically the same principle. So let's use a very simple scenario where you have 60-degree angle, triangle all around, so they're all same. So here are these steps. Basically, step number one is to find the reaction forces at each support point. So you have already know that from previous chapters. So basically, you remove the support at point A, and then basically do the appropriate reaction. We had a pin connection, so we'll have both the vertical component and horizontal component at A, and then B has only rolling contact, frictionless surface, so it will only have the perpendicular reaction to the surface. So it's going to be only vertical component. Now this 700 pound is going to, the line of action of that 700 pound is basically all the way to the down like this. So this distance will be AB by 2. This is also AB by 2. So the first step, when to draw the reaction, to find the reaction forces, you have to draw the free body diagram, have all the appropriate reaction at both support points, and then take moments at any of those points to find the reaction at the other point. So if you take moments with respect to A, so then we'll have the 700 will cause A. So with respect to point A, so the 700 will cause a clockwise moment, so that's going to be negative, and it is AB by 2 away from point A, and then the reaction at B will cause a positive moment. So this VB will do a counterclockwise moment, VV times the distance, which is AB from A, and everything summed to 0. Then we can calculate the vertical reaction at B, which is 350 positive. And then you can take the moment with respect to B, everything summed to 0. You're going to find the exact same thing in this scenario. However, it's going to be for the vertical component for reaction A. So that's going to be plus 350. And you also need to verify your calculation by doing Fy is equal to 0. So if you sum all of your calculation, you did 350 plus 350, which will be exactly equal to the external force right here, 700. So the first step number one in analyzing a structure, is to find the reaction forces. Next, we are actually trying to find out that how much each of these members is carrying. So for example, this bicycle frame, how much is bottom tube carrying the load coming from this from this, right? So how much it is in this frame member. So this is our goal, to find out the individual forces acting on each of these member. Now to do that, the internal reaction force, the internal resisting force. So the way we say it, if you want to see inside, you have to cut it. So they basically cut it and then ignore everything on the right side. You only look at point A, so whatever that left in point A. So if you do redraw point A here, so you're only keeping point A. So you got a vertical reaction at 350 pounds, and then AB is acting in this direction and AC in this direction. Remember, we're not seeing the point B or C. We are ignoring everything to the right side. This C, AC and BC, is just for our notation of this force that we are calling that AC, and this force we are calling AB. So very simple thing, you simply apply that summation of force, moment, everything equal to 0. So summation of, if you write summation of Fy is equal to 0, upward direction positive, so that then we can do AC sine 60 degree plus the component of AC to the vertical direction is AC sine 60 degree plus the 350 reaction force also acting upward vertically, everything summed to 0. So therefore AC would be, I calculated, minus 404 pounds. So this is negative, meaning that the direction we assume, upward direction, is not the actual direction of the force. So it is actually acting to A, not away from A. Now when a force is, if you're looking at point A and if it's compressing that point, is pushing that point, then we call that this force is in compression, so with the notation C. And then let's do that summation of Fx is equal to 0, that will give us the other force. So the Fx direction, we have the AB force, which is positive to the right direction, plus AC cosine 60 degree, that also to the right direction, everything summed to 0. Now if you plug AC here, which is negative, so we can calculate the AB. I found plus 202 for AB. Let me double check my number. Yes, approximately. So now this AB is acting exactly the way we assume, to the right direction. So you're looking at point A and this AB force is pulling that point. So if it's pulling, then it's in tension. So when you finish working all of these, finding all of the forces, so you can do similarly cut point, look at point B and find all these forces, and you have to finally redraw a triangle to complete the process. So for this A, C, B, here we got 350 in this case, here we got 350. So that's 700 pound coming from the top. So these are the reaction, and the internal force at by the AC member is compression, which is acting to AC. So that's going to be 404 compression. And here you do in this direction, because like I said, if a point is pressing the point you're looking, then it indicates compression. So you have to have a direction right here into C. However, for AB, it was pulling. So it's going to be like this, but the force was 202. And if you look at point B, it's going to be pulling like this way. Now the AC and BC member will have the exact same thing. So we'll just simply do this, and then pressing this B and pressing C, and the same force, 404 compression. So this completes the process. So simply first you find the reaction at each point, and then you look at each of these different joints, or simply cut and just keep only one joint to do the analysis, and that basically completes this analysis. So out of this 700 pound force, the AC member will carry 404, BC member will carry 404, and it is in compression, and then AB member will be in tension, but it will only carry 202. If you look, just apply some, not even, you don't have to be in math class to know that if a force is coming this way, this member will be in compression, this member will be in compression, and because it is attached at A but it is a rolling contact at B, so this point is free to move, so then this member will be in tension.